Welcome and hello. This is a video tutorial on HEC RAS, and in this lesson, I'm going to be discussing viewing results, specifically the 3D view results, hydrograph results, and then various table results. Okay, so what I have on the screen here is my HEC RAS. At the top window here is the files, and then below that I have the geometric data opened up. What we're going to be looking at in this lesson specifically is if after you run a model, steady flow or unsteady flow in this case, if you go up to the view menu here, I'm going to be covering everything from 3D view all the way down to summary, error warning, and notes. The previous lesson covered cross sections down to rating curves if you're interested. All right, so before we go ahead and look at these different model results, I wanted to just quickly show you what the model is. It's a single reach with a number of cross sections from river station 0 down here at the bottom of the reach up to river station 20,000, which is at the top of the reach. The invert along this channel is a constant 0.2%. And I do have a few structures, such as at river station 5,000, there is a bridge. At river station 9,000, there's a culvert. And then I have a lateral structure at river station 13,000. I'm going to go ahead and zoom in on those real quick. So view, zoom in. Let's just go right here. This should include the bridge here at 5,000, the culvert at 9,000. And then let me just pan up to the lateral structure. Oops, okay. Didn't seem to work. View, full plot, and then view, zoom in. This is the lateral structure right here. All right. Here is the lateral structure. That's the side view of it off the left bank. And then for the bridge and culvert, this is the culvert. This is at river station 9,000. And then the bridge is right here at river station 5,000. Okay, as far as the flow data, let's bring that up. This is unsteady flow. I have a flow hydrograph defined here at the top of the reach. 20,000 is the river station. If I double click on that, I have the flow hydrograph. It starts at 40,000. It ramps up to 100,000 CFS and then back down to 40,000 over a 4-day simulation starting in January 1, 2025. Okay, so let's go ahead and run that. Everything's saved and ready to go. We'll go ahead and click compute. All right, that looks successful. So I'll click close and now let's get to those results. I'll go view and then 3D view. And now what it says here is new 3D viewer requires an output file to exist. If you want to launch the old 3D viewer, and I'm not quite sure what that means because I do have an output file right here. But anyway, let's just go ahead and click yes. It's going to bring up this XYZ perspective plot. This is what they mean by a 3D viewer. And this is the same dialog box and interface that will pop up if you click on view and then XYZ perspective plot. So this is the perspective plot right here. We have the top of the reach, water flowing down, the bottom of the reach at river station 0. We have the bridge structure. I don't know if you can see it too well. Culvert, and then I don't see the lateral structure, but it would be right here. There are a lot of features in this perspective plot that we're going to examine right now. For instance, we can control the upstream and downstream reach or the range. Now, right now it's set at the total range, but if I wanted to focus in on just this bridge right here at river station 5,000, then I may set the upstream to be 6,000 and then the downstream to be 4,000. And you can see it updates as I make those clicks. So now we have the bridge. And if I wanted to rotate, I could use this rotate tool or rotate the other direction. You can see how that works. And then there's also an azimuth angle rotation. So I can look down on the bridge or I can not look down on the bridge. I can look kind of across. So that's how that works. The culvert is further upstream at river station 9,000. So if I wanted to set this to say 10,000, now I can see the bridge and the culvert. If I wanted to see just the culvert, I would switch this to 8,000. And now we have a similar plot of the culvert itself. If I wanted to print, I could go File, Print, and then this would print out to any device that my computer has a printer driver installed for. So like a PDF or any of the like an actual printer. If I wanted to print this image onto a piece of paper, let's go ahead and print it to PDF, and then we'll just say landscape, and I'll just assume all the default values there and click print. Okay, so it's going to be called ras.pdf on my desktop. I'll just say okay. Here is the PDF file. And then, all right, so this is my PDF. Obviously, I can add different details to it and then print it out again. I can also copy to clipboard. I believe that just copies the image to a clipboard. So if I wanted to paste it as a, into an image software and then save that as a JPEG or a GIF or something. Okay, let me just go ahead and try it and then paste. Yeah, so that would just paste as an image. Let's go ahead and animate this now. Okay, backed out to the full screen here. And then a few of the options, as you can see, are zoom in, zoom out, full plot. If I wanted to zoom in, I could just do a manual zoom in like that. There's also full plot, pan, and animate. Animate's pretty great. If I want to animate and go through the different profiles, then I can do that using this control right here. In unsteady flow, and this is an unsteady flow model that I ran and we're looking at results for, then the term profile refers to the different time steps. So profile one would be the first time step. You'd have 96 profiles in the case of a hourly time step over the course of 4 days. So that's what we have here. What you see here is January 1, 2025 at 0 hours. And if I click the right arrow, it's going to advance to the next time step, the next profile, which is 1 hour. And I could just do that a number of times. Now, right about hour 4 and 5 is where the hydrograph picks up and increases from, what did I say, 40,000 up to 100,000. So let's just click through the next 5 or 6 hours and take a look at the water surface and then see it rises specifically behind the culvert right here. And then I'll just keep clicking. That's 9 o'clock, 10 o'clock, 11, 12, 3 p.m., 4 p.m., and then it goes back down. So we're going to see this hydrograph a few different places in the results. In fact, we could even zoom in a little further. Options, I'll zoom in right here, and then I can change those angles as before. Okay, so this is more of a side view right here. And then if I go back to options, animate, it looks like it's on okay, it started over at the beginning. So let's just advance to that high water location right about here, I'd say. Maybe about noon on the first day. You can also play this through like a play bar just by clicking the play button. So if I click play, it just plays through. And then again, that was a little bit quick. So you can click the ellipse button to have some control over the playback. Here's the ellipse, and then this is fastest, and I believe this is slowest over here. So I'll put this right in about the middle, and then let's play it again. Okay, so this is quite a bit slower, but you can see that it's animating, and you may want it to animate slower when you have more things to look at. All right, so I'll go ahead and stop that. So that's the 3D view or XYZ perspective. I'm going to go ahead and close that. Next, in the view menu for view results, we have stage and flow hydrographs. So I'll go ahead and open that up, make this window a little smaller here. This is the stage and flow hydrographs, as it says, for the different profiles or the 4 days of the duration of that simulation. We have time series data here. There's a rating curve right here. And then internal boundary curves are the three tabs that we're seeing at the top. So I'm just going to go back to time series for now. There's also different controls you can see up above. Right now it's showing the river station is at river station 5,000. That's at the bridge. And then there's also 9,000, and that's the culvert. The reason why we're only seeing the bridge and the culvert in this drop down is because the type is set to bridges/culverts. But if I wanted to see cross sections, lateral structures, or any of the other elements that currently are grayed out because I just don't have a very complex model, then you go ahead and make that selection from this type menu. So I'm going to change the type to cross sections. And now what I have is a list of the different cross sections. These are only the cross sections that are upstream and downstream of those particular structures though. Okay, I'm not seeing it here. So let me go ahead and rerun the simulation for all the cross sections to show up here. Okay, so if I go run and then options, stage and flow hydrographs, I'm going to just double click them all. Okay, compute. Okay, so I'll click close. Let's go back up to view, stage and flow hydrograph. Now for the type, if I go cross sections, all right, great. Now like I've got all the cross sections. It's every 2,000 feet. So I've got some interpolated cross sections. Yeah, of course, I would see the cross sections for the lateral structure, the bridge, and the culvert if I select bridge, culvert, or lateral structure here. So if I click lateral structure, there's that data. Okay, almost too much information to talk about in a single lesson. I'm just giving you a quick little preview of what I think is some of the more pertinent, important information. All right, so let's go ahead and just select, how about River Station 6,000? So we have the stage we're plotting, the flow rate we're plotting, and then also observed and stage and flow data if available. Now, there's actually no observed stage and flow data, but you can see this data right here. It ramps up, it ramps back down, which is consistent with the flow hydrograph. The units of elevation are here on the left vertical axis, and then the units of flow rate are here on the right vertical axis. I can also toggle them off right here. So now I'm only seeing stage, and then not here I'm only seeing the flow rate. I can also get the data if I click on this table tab right here. Okay, I'm going to make this a little bit wider. Then I think I can drag this over as well. Drag that over. Okay, so now I have the actual data. So for every hour or every time step, I have the stage, the elevation in feet, and then the flow rate, which is in CFS. I also included observed data. That's why I believe it says OBS right here. So if I click OBS, and then let me toggle off the table. So, oops. Okay, now I'm back here. And if I wanted to see that observed flow data, I'll just click this on right here. I made up some dummy observed flow data just to demonstrate what that looks like here. And I made it to be about 10% of the actual flow data, so you can actually distinguish it from the actual flow line. So let me turn off the plot stage. Now what we're seeing is the actual computed flow and the observed flow that I just made up. This observed flow can be entered in the, if you go up to edit and then unsteady flow data, and then click on observed flow. I went ahead and added that record right here. First, what you need to do is add the cross section. So you'd select the cross section. I went ahead and selected 0, add the cross section, boom. Okay. After that, you can click edit down here in the observed flows table, edit, and then just enter the data here via table, DSS, or a constant value. Okay. Anyway, that is all covered in a previous lesson, but let's go back to the results. And then we would see that here in an observed table data. If I wanted to see that observed data compared to the actual data for a flow, I could open up the table. Now we have the computed. Here we have the observed. All right, up here in the top right, we have a highlights table, some statistics that basically say the stage flow and observed flow for the maximum value, as well as the time to the maximum value. And then it looks like we have the total volume as well. Remember, this time to maximum volume is only to the nearest hour because that is the time step of the simulation. In the options menu, we have the ability to change plans. I only have one plan, but that's where you change it. The next option down is the number of decimal places. So right now it says 2, but it can be between 0 and 9 if you want extra precision. Variables right here, flow and stage, that's pretty self-explanatory. And then show difference. So if I wanted to see the difference between, let me toggle off the table here. There we go. If I wanted to see the difference between the flow and observed, then that's what this top plot is right here. All right. All right, let's go ahead and close that up. The next option down here in the view results menu is hydraulic properties table. Oh, yeah, this one didn't work for me. We've already encountered that. Okay, next in the view is the detailed output table. Detailed output tables show hydraulic information at a single location for a single profile. So what we have here is type. And you may recognize this from before. The type menu, we either click on cross-section, culvert, bridges, or lateral structure, or any other structures or elements that we have in our geometry file. Let's go back to cross-sections because this is a good place to start. Plus, we have all the cross-sections listed right here. What we need to select is the river, and then the reach, and then the cross-section we're interested in, and then the profile as well. Now, remember, the profile is like a time step, so we could use the very first time step, the second time step, the third, which is the third hour, the fourth hour, and so on. Defaults here to the maximum water surface because modelers may most likely be interested in what is the maximum water surface, how does that affect the rest of my model. So let's just go ahead and stick with that. What you're seeing in the table data here is, as I mentioned, it's the hydraulic information at a single location at a single time period, single profile. So we have energy grade line. That's a lot of this is calculated information like the velocity head, the water surface elevation, and so on. If you're ever unsure what data you're looking at, down below there are a couple text boxes. The very bottom text box actually is an explanation of the cell you clicked on. So flow rate total, that's pretty straightforward. It's 100,000 CFS. If I click on that, it says total flow in the cross section down here. Next one down is top width, 352.67. So if I click on that, it'll tell me the top width of the wetted cross section. I can do the same thing over here. So top width right here, this is for the left overbank. Top width of the left overbank does not include islands, but it does include ineffective flow. And then if I click on the actual value here for the channel, it's going to say top width for the main channel. So it's a nice little reminder if you forget what something means, or maybe the abbreviation is confusing. The next text box just above that, but still at the bottom of the dialog box, is for errors, warnings, and notes. You can go ahead and read these. The one here says I should probably add a few extra cross sections, so that's my fault, but it's just a warning. Warnings are yellow, errors I believe are red, and then notes are in green. A few other menu items. We have file, we can copy to clipboard, print current, print multiple, or exit. Type, we talked about that. And then over in options, we can include or not include the interpolated cross sections. So right now we've included all the interpolated cross sections, the ones that have this asterisk mark. But if we wanted to toggle that off, for instance, we were only interested in the non-interpolated cross sections, we would go options, check that off, and then boom, now we have far fewer cross sections to select from. I'm going to turn that back one on though. Options include the errors warnings in the printout and then unit system for viewing. So if I wanted to see these values in the metric unit system for whatever reason, then boom, that conversion was made. Here are the values, but let's change it back to the US customary units. All right, so that's it for this cross-section output data. I'm going to go ahead and close that. Next up in the view menu is the profile summary table data. Make that a little smaller. This table shows flow distribution in a cross-section at the same time. So it shows you the different river stations and then all of the data for those river stations. As you can see, there's a lot of data here, even for such a very simple model. Along the top, we have our menu items, and I'll talk about those now. Starting off with this one, standard tables. So right now we have a number of different standard tables, and by default, it's going to show you standard table 1. And what's included in standard table 1 is what you're seeing on the screen here. It shows the reach, the river station, the profile, the total flow rate at that river station. So this is pretty interesting, actually. We have, hold on, I think I need to make this a little bit wider because 0 doesn't make sense. I believe this is 100,000 CFS. Okay, so I made it a little bit wider. There's 100,000 CFS. All right, so it's basically 100,000 the whole way down. Minimum channel elevation. So this is the channel invert. It starts at 70, and then over the course of the next 20,000 feet, it goes down to 30. So that's 0.2%. After that, we have water surface elevation. So this is sort of a mix of calculated values and given values, like the geometry itself is given. But water surface elevation, the critical water surface elevation, energy grade line elevation, slope, channel velocity, flow area, top area, and then the Froude number. All right, so that's just one table. That's just the standard table. You can go to standard table 2, for instance, if you wanted to see some different data, like the energy grade line, water surface elevation. Some of this is the same here, but now we have like friction loss. This friction loss column will report the friction loss between the cross section of that row and then the cross section of the next row down. We also have the flow rate over the 3 different areas between left overbank, main channel, and right overbank. It looks like there is some flow over the left and right overbank at that culvert, just upstream of the culvert, which is at River Station 9000, which kind of makes sense. In fact, I know it's not part of what we're doing here, but I want to check out the cross-section data and then just see what it looks like at the culvert. So this is at the bottom of the channel, and then we go up 4,000. This is the bridge, the downstream side of the bridge. This is the upstream side of the bridge. 6,000, 8,000, and then, okay, so this is the culvert. This is the downstream side of the culvert. This is the upstream side of the culvert here. And yeah, so we have definitely some water flowing over the left and right overbank. And this is River Station 10,000. And I believe 12,000 has a little bit as well. Yep. Okay, so just keep that in mind. 10,000, 12,000, and then upstream of that 14,000, it's no longer flowing over the overbank. So let's go back to that table here. And this is exactly what I expected to see. We have some flow over the left and right overbank. That's at 10,000 and 12,000, but then not at 14,000. The lateral structure here is, the invert is too high for any flow to go through it. Okay, let's go through a few more of these tables, but not all of them. You kind of have to explore which tables that work best for you. For XS culvert, this is the 4 cross sections surrounding the culvert, 2 upstream and 2 downstream. Our culvert is at River Station 9000, so we have a cross section at 6 and 8,000 downstream, 10 and 12,000 upstream. Okay, the next table is culvert only. After that, we have 6SX bridge. So that's going to show you the bridge upstream and downstream, as well as two cross sections downstream and then two cross sections upstream. So I'm going to go ahead and let you just explore the different standard tables. I don't want to spend too much more time talking about them. All right, so standard table one. The next menu item over to the left is options. Here we can demonstrate different plans. We only have one plan though. We have different profiles. So this is interesting. Right now, we're only set on the max water surface profile. But say, for instance, we wanted to see the profiles, i.e. time steps for the first 4 hours. What we do is we toggle off this max water surface, and then we'd add in 0, 1 hour, 2 hour, and 3 hour into our simulation. And then when I click OK, watch the table expand vertically because it's adding a lot more rows. So what I'm seeing here in the first 4 rows of data in the table is the same river, reach, river station, and then it's going through the first 4 profiles or the first 4 time steps for the start of the simulation, and then 1 hour later, 2 hours later, and then 3 hours later into the simulation. This could be really helpful if you're interested in looking at the data in this fashion. So just to let you know, there's a lot of different ways to organize and view the data in these tables. All right, so I'm going to go ahead and just go back to the maximum water surface elevation here. That's this one right here, and click OK. All right, the next option is reaches. There's only one reach, but you may have a situation where there's multiple reaches. Options include interpolated cross sections. Yes, we want to do that. I like to include all of these notes, which is like the notes up here, so I can see what I'm dealing with. Table cross section order, so I can go downstream to upstream or vice versa. And then after that, it's standard table number of decimal places. This is a good one. For instance, if you wanted to see more precision in some of your numbers, for instance, the flow rate is to the nearest 2 decimal places of CFS. The minimum channel elevation, this is the invert, of course. That's to the nearest 2 decimal places again in feet. So you can change that to 3 or more, or I believe it goes up to 9. Yeah, so for slope, you're going to want to have a lot of decimal places, and it's up to 6 right there. In fact, for Froude number, you may also want to increase that. So let's increase the Froude number of decimal places to 3. Oops, there's 3. So if I click OK, now the Froude number precision is a little bit better. Typically, as an engineer, I like to see at least 3 significant figures. All right, so next up is the unit system. Again, we can switch that over to metric. Last, we have define a table, save a table, and remove a table. This is a way for the user to specifically define the table for themselves. If you don't like any of the standard tables, or you would probably start with the standard table you like the most and then make some modifications. So if I wanted to start with standard table 1 and then go to options and then define table, what it does is it starts me off here with this dialog box where I can add or remove different columns from the table and then save it as my own separate user-defined table. So just to be real quick and easy, I will create a table from standard table 1, which is what I have set here. It's my starting point. And I'm going to make it just how about just the water surface elevation. So I'm going to select all the other columns and then delete them. So I'll delete that minimum channel elevation. This is the one I want to keep, water surface elevation, and then I'll delete that. Delete, 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 delete. Okay. So if I click OK, I believe I can now save. This is the table, so I can make sure this is what I want to see. And maybe I want to make it an extra decimal place. We can go options, number of decimal places, change that to a 3. How about a 4? Why not? So we have 4 decimal places, and then option. I'm going to save this as a table. I'm going to give it a table name, water surface elevation only. Then I will click OK. Now what happened is I now have this new menu up at the top that says users tables. So if I wanted to go to a different standard table or the culvert only table, these are the standard tables. But if I wanted to look at my water surface elevation only table, here it is. All right, you can also delete the user tables by going to options, remove table, and then select the one you want to delete. Click OK, and then I believe it's gone now. So let me just go back. Yeah, so it's gone now. The menu has disappeared. In the file menu, we also have a write to text file. That's an option I hadn't seen before. Okay, so I'll just call it test.txt. I'll save it to the desktop and click save, see what we get here. All right, let's open up this text file in a text editor. And here is the data for that text file. All right, enough time on that. All right, the next and last one is summary, error warnings, and notes. So if you click on that, you get a dialog box that just displays all the warnings, notes, and errors from the simulation. And you can specify the river, the reach, the profile, and then the plan as well. So if you ever wanted to organize the notes, plans, and warnings, the only thing I would actually change about this is add a filter for warnings, notes, and errors, because the user may only want to see what are the errors, what are the warnings, what are the notes. But it looks like they're all together right now. Yeah, there's some notes right there in green. Okay, so that was it. Let's go ahead and make sure that is the last one. Yep. So what we did in this lesson is we ran a unsteady flow simulation in HEC RAS, and then we went up to the view menu and we looked at the different ways to view the results, starting with 3D view and XYZ perspective plots, all the way down to summary, error warning, and notes.